Hello, and welcome to the Fascinated by Fungi podcast. I'm Dr. Gordon Walker, and today we're going to try talking about medicinal mushrooms and the potential for mushrooms as therapeutics and drugs. And first, I want to say the last couple of weeks I've played around with different ways of recording the sound, and I think I'm still figuring out exactly what the best way is. So I'm trying a new microphone on call-in this week and seeing if the audio quality will be a little bit better. In future podcasts, I will be soliciting people to call in and actually ask me questions on the call-in app. So hopefully you will have learned enough from the first 10 or so episodes of my podcast that you can ask me some good questions and we can have some really cool, fun, dynamic discussion. Today, though, we're going to be jumping into medicinal mushrooms. And this is a complicated topic. I talked about this at Soma Camp the last time we were actually able to hold camp before COVID has unfortunately canceled the last two. And I tried really hard to research the subject and put together a presentation to the best of my ability with good data and good figures that was based in science. And I cited all my sources, which is a thing I think is important to do when you have this kind of discussion, because there's a lot of hand-waving and strong opinions, especially about medicinal mushrooms and what people think they can do for them, but not as much actual data, especially when it comes to like clinical human data. And so I put together this presentation and I gave a talk, and I thought I did a pretty good job trying to kind of balance the potential for medicinal mushrooms with a little bit of skepticism and sort of a scientific bent on, I want to see the data. And at the end of the presentation, it seemed well received, but I had several people come up to me afterwards and throughout the course of the night and essentially tell me that I was a bad person, that I had offended their sensibilities, and that I should not talk publicly and I should just essentially go off myself because of being skeptical of some of the things about medicinal mushrooms that I had been skeptical of. So I preface this by saying, if you are fully into drinking the Kool-Aid on medicinal mushrooms, you may not enjoy this podcast episode, but I think it's worthwhile to think critically about some of the claims that are being made, particularly with regards to health and the way that mushrooms can impact our health. So I'm going to try really hard here to just look concretely at some well-defined fungal derived drugs that are currently being used in medical settings to save lives and all over the world, accepted by doctors. These things are very well characterized. These are things that have been turned into particular drugs by big pharmaceutical companies, and there's not necessarily anything inherently good or bad about a drug that's been made into a drug by a pharmaceutical company. It simply means that they've done all of the work to push it through clinical trials, bring it to the FDA, do what's called GMP, but certified guaranteed manufacturing processes to define how that drug is made. And this is a very different approach than just sort of taking a little vial of tincture and putting some into your morning coffee or something like that. When drugs get turned into pharmaceutical drugs, there is a whole level of understanding that we gain into their clinical usage and their effects and their dosage and their localization, all this kind of stuff. And I'll be sort of talking that as we go along. But I just want to point out that there is a big difference there between something that has been sort of like defined as a drug and recognized by the FDA versus something which is just sort of a natural product or an extract that you might buy at like the farmer's market. And I think that's a thing where people's lack of science literacy and critical thinking skills there's a divide there that's not necessarily easily bridged because of cultural factors and people having very strong opinions about what constitutes medicine and having often negative feelings towards these big pharmaceutical companies. I can't say that I have super shiny feelings towards the big pharma companies because they make an absurd amount of money and they charge a lot of money for their drugs. However, they are also responsible for saving thousands, if not millions, of lives by producing these drugs. So there is kind of a give and go there between, um, you know, real medicine and then kind of what people like to wave their hands and generate a lot of hype about. So I'm going to just try to present a little bit on both sides of this and dive into the science with you guys. So when thinking about fungal derived drugs, the number one thing that I think we should all keep in mind is probably the most important potential drug of all time as it relates to modern medicine was the advent of the antibiotic penicillin. So penicillin, sorry, there's a lot of cars going on outside. Penicillin is from the mold Penicillium. And this was discovered sort of pre-World War II, I believe. And it was essentially contamination on a plate. There was a petri dish and a mold spore came in, a little mold colony grew up. And the scientists noticed that there was, there had been a lawn of bacteria, a complete overgrowth of bacteria on this plate. And where this mold colony was, there was like a halo, a ring of where there was mold and then no bacteria. And they started looking at this fungus and realizing that penicillium mold, which is actually penicillium is the same kind of mold that grows on brie, bloomy rind cheeses. It's also on a lot of salamis. This white, puffy looking mold produces a compound which inhibits the growth of bacteria. And I believe it's gram-negative bacteria. So it's, this is a pretty common thing that a lot of molds and mushrooms and different fungi live in complex microbial communities. And as a way of manipulating their environment, because fungi are very good at this kind of thing, at being kind of opportunistic and sitting in a complex community, but being able to carve out a little niche for themselves, they use stuff like antifungals, antivirals, antibiotics to give themselves a little foothold, to create that niche where they are allowed to do their metabolism at their own rate, rather than trying to compete against bacteria, which grow much, much faster than fungi. But fungi have this capacity to generate more compounds through their complex genomes and ability to do secondary chemistry, where they create some of these compounds that helps them kind of do their business. So penicillin is a great drug. At this point, as an antibiotic, it has reduced its efficacy because we've been using it nonstop for the last 70 years in pretty much everything from hand soap to chicken feed to you name it, they put antibiotics in it. Because for some reason, people are very scared of bacteria, even though we are full of bacteria. We're literally walking, talking bioreactors with more bacterial cells in our guts than we have actual human cells in our bodies. But again, people are very afraid of germs and microbes and bacteria, so they stuck penicillin in everything. And unfortunately, because of that, bacteria have developed a lot of antibiotic resistance. So antibiotics often target a single part of transcription or translation. There's some element of which this molecule gets in there and kind of screws up some fundamental biological process within the bacterial cell. But bacteria are really good at circumventing this kind of thing. They kind of just keep mixing up their genome and keep slightly changing proteins and stuff like that until the thing that's inhibitory, they've created a workaround. And that's often what antibiotic resistance is. In modern medicine, they've figured out that often if you pair multiple antibiotics together or you pair something else that puts stress on the system, you can restore the efficacy of that particular antibiotic by adding a little extra stress. And often you can actually reduce the dosage of particular antibiotics by pairing multiple kinds of antibiotics together. Unfortunately, we've used so many different antibiotics that there's so much drug resistance out there. Bacteria have the capacity to kind of trade drug resistances it's like trading cards kind of thing. They do one of these little circles of DNA called plasmids, and they have these little sex pili. They go out and exchange pieces of DNA as if they were trading baseball cards or something like that. And they're able to accumulate these types of resistances. And so we have these sort of superbugs that are running wild in hospitals and killing people because all of our derived antibiotics are no longer functional against these superbugs. But that's sort of a separate issue. However, fungi are one of the places we're turning to mine new novel antibiotics and things that can help us kind of get around the adaptability of bacteria, because fungi have been dealing with bacteria for literally millions and billions of years, and so they've evolved a lot of things that we can take advantage of. And that's one of the great places where preserving fungal biodiversity gives us a lot of strength and buffering capacity to help fight, the challenges we face in modern human health. And so that's a good thing to remember too, that in untapped biomes or areas where, they're going to rip down this forest and build a, for cattle, or build a shopping mall or something, like, hey, maybe the next great cancer drug, or maybe the next great like antibiotics, is actually in a fungus in this forest, and we shouldn't just destroy it. It's a way of looking at nature that is a little less sort of colonizer centric, and a little bit more like, hey, maybe we could live in community with nature and preserve parts of it, instead of just wholesale ripping everything out and assuming that we can do better by building things up with steel and concrete. But it's a philosophical discussion for another time. So another cool drug that is currently in use is Cyclosporine. So this is derived from Takigrifle, which is this really cool like deer truffle kind of thing. They're essentially little like parasitic ascomycete fungi that grow on other mushrooms and produce a weird little thing. Kind of looks like a cordyceps. It's related in some ways to cordyceps. It is not a cordyceps, but it looks like one, and it has sort of similar biology, except for it doesn't infect insects. But this is one of many immunosuppressant drugs that have been derived from fungi that's really important for stuff like organ transplants, because people get a new organ transplanted, and cell surface markers from an organ versus your body might start attacking your new kidney as like a foreign object, and that's very bad. So sometimes people get these organ transplants, and they'll be on immunosuppressants possibly for the rest of their life, as long as they have this implant organ. And so a drug like Cyclosporine has been very, very important against thousands and thousands of lives. There's stuff like levastatin and statins in general, which have been derived from Aspergillus, the same kind of fungus that is used to make like miso and sake. There's also, Aspergillus. There's Aspergillus oryzae, which is the one they use for food, and then there's Aspergillus niger, which is like a very pathogenic thing that produces a lot of mycotoxins. And within both of these, there's potentially statins and drugs to be mined, but it's kind of interesting because like one is this thing that's associated with food and it's really happy, and another one is like associated with like rot and mold and death. And it's not that inherently one organism is bad or good, it's just that they produce different types of things, and humans have sort of cultivated one of them into a thing that's pretty safe, and the other one continues to be this sort of wild menace to us. But either way, there's things there to be understood and mined out of it. But you wouldn't just take a bunch of Aspergillus to sort of say, oh, I'm getting the benefits of the statin drug. No, you have to like take that organism, understand the biosynthetic pathway for the production of this bioactive molecule, take that pathway, express it in something else, and make a lot of these statin molecules to then use as a drug, and understand the dosage, the purity, all the things that kind of go along with generating a drug, because just eating lots of Aspergillus doesn't necessarily give you the benefit of this bioactive compound. And I think I'm going to go into this more later, but that's a very important point, that understanding that something contains a bioactive molecule that could be a drug doesn't mean that consuming that organism in its natural form will necessarily give you the benefit of that bioactive molecule, right? There's another great drug called Taxol, Plaxitel or something like that, I think is the science name for it. Taxol is the sort of branded name. And this is a really interesting drug. It is something that inhibits microtubule formation. So inherently, it's toxic, right? If you inhibit microtubules, you're inhibiting cells in our bodies that are growing quickly. So the side effects of taking Taxol as a drug is you lose your hair and your skin gets really bad. Everything that's a quick growing cell in your body potentially gets inhibited by this drug because it is a toxin. But it's a toxin that targets fast-growing cells, and so it's been very effective against cancer cells, which are the ones that tend to grow very, very quickly. They've lost their cell cycle regulation, and they're just growing wholesale, creating tumors. And so adding Taxol to chemotherapy has been a way to greatly increase the
death of cancer cells, and while there are health consequences for it, you can save your life. So like losing your hair for a couple of months is better than dying from a tumor. And I think very importantly, like this is an interesting drug because Taxol was discovered in the Pacific yew tree, and they realized pretty quickly that they couldn't cut down enough yew trees to isolate enough this drug for it to be relevant. And as they dove into, where does this drug come from in the yew tree, they realized that the drug is actually being produced by an endophytic fungus that lives inside of the yew tree. And as they dug even deeper, they found that that endophytic fungus is dependent on the presence of a particular bacteria to produce the Taxol molecule. So in that sense, it's this crazy community dynamic that created a drug that is toxic to us, but more toxic so to these tumor cells that are within us. And so again, that's kind of an interesting thing about like, what is toxicity, what is not, and then how is this all dependent on a community dynamic? And Taxol is a drug that they give to cancer patients. And there's a very famous mushroom person out there who tells a story of how his mother had breast cancer and how he fed her turkey tail extract and how her breast cancer was cured. What he fails to mention and omits from this story is that Taxol is the drug that doctors were giving her to help save her from her breast cancer. And whether or not the turkey tail extract did anything, there was real clinical fungal drugs being given to her that saved her life. And I think it's somewhat disingenuous to go around telling a story about how you fed your mother turkey tail extract while omitting that the clinical doctor side of things were actually using a fungal derived drug rather than saying, I use turkey tail extract, hey, buy my turkey tail extract. I think that is very disingenuous of the person who does that. And I know a lot of people in the mushroom community have taken issue with that particular story and narrative that that person has created. So I won't say who, but I think you all know if you're a mushroom person. So another interesting one is Amitoxin. So amitoxins are the deadly peptides that are in Amanitas. And they are small peptides that when they bind to RNA polymerase II in your liver, that inhibits all transcription. So your body's ability to turn DNA into RNA shuts down in your liver. So your liver ceases to function and you get very sick. Then you get slightly better and then you die. And this takes about a 7 to 10 day arc after consuming one of these amitoxin containing toxic mushrooms. So that's the Destroying Angel, the Death Cap. There's some other things that have amitoxins as well, lepiotas and gallerinas, and et cetera. This is a very toxic set of small molecules, these little peptides that can inhibit this, this very important enzyme. But in very small limited doses directed to particular tissues, again, they're seeing ability of this can shut down a tumor, or this can help destroy certain cells that are like overactive or something like that. And even as part of the basis of our understanding of molecular biology, the Cronenbergs, who are two very famous, as a father and a son, very famous scientists who helped define some of the original biochemistry of how these enzymes, the RNA polymerase enzymes, worked, used amitoxin as part of their assay and their methods for understanding the basic molecular mechanisms of what transcription was. So I think that's fascinating that here's this peptide, this toxin that can kill us, and yet in small doses or in clinical and scientific settings, it's a drug that has potentially very positive outcomes for our understanding and for our health. And I think that's a really important point, is that dose makes the poison with a lot of this stuff. And our capacity to understand fungi has a lot to do with like how we approach it, right? Because even things that are toxic could end up being positive drugs and could help us save lives depending on how we use them. It also brings up the idea for me is, if you're going to take mushrooms as medicine, or you're going to look at fungi as medicine, what are you treating, right? Because I think a lot of people are sold this idea that somehow taking these pills and these supplements and things like that will somehow make them like a superhuman, which is, again, this is a thing that the supplement industry does to people all the time, where they try to convince them that like, hey, buy our thing, buy this mega mix, this blend, this whatever, it'll make you so healthy. And my question is always, well, what's in your mega mix? What constitutes that? What is the activity of the stuff in there? And they rarely, if ever, tell you anything close to that because they don't know. They're just buying stuff and shoving it in pills and often using a bunch of fillers. And then if you're taking mushrooms as medicine, what are you taking them for? What are you trying to treat? And I think that's a really important thing. It's like you wouldn't just take cough medicine every day unless you have a cough, right? So if you have a cough, great, go take cough medicine. But if you don't have a cough, then why would you take this thing every day? And I think that's a thing that like supplement brands are not being honest about, because they tell you, oh, take this daily supplement, take this thing. And you're like, it'll have great health consequences. And you're like, yeah, but like, what are you trying to treat with this? And I just think that's a very important point that is lost a lot in the discussion about medicinal mushrooms. Is if mushrooms are medicine, and I do believe they can have positive health outcomes, what kind of positive health outcome are you trying to achieve? So with that all being said, I'm going to dive a little bit into what are some of these sort of biochemical constituents of medicinal mushrooms, and then what are some medicinal mushrooms that we can talk about, and we'll kind of go from there. So the big one that you hear about all the time when people reference medicinal mushrooms are beta-glucans. And the question is, what are beta-glucans, right? You'd see it all the time on mushroom labels and things like that. Oh, like 70% beta-glucan. Yeah, but what is that? So fungal cells are composed of a lipid bilayer, similar to animal cells. And then on top of the lipid bilayer, which is sort of just this two sets of fatty acid molecules that are sort of moving freely, and this constitutes a cell, creates a little bag of enzymes and DNA and all sorts of stuff inside. That's what a cell is. On the outside of the fungal cells is layered bits of manoprotein, chitin, which is a fungal-specific polysaccharide, just like plants have cellulose. Fungi have chitin. Some animals have chitin too. That's what insect and arthropods and crustaceans are made of, chitin. And then there's like layers of beta-glucan, which again are basically complex starches. They're polysaccharides, as is chitin, but they're all linked differently. So when we think of starch, we think of something very simple like amylose, which is just a big long chain of carbon, essentially, very simple linkages. But these different kinds of branches and linkages, so instead of just a simple chain, you can have a lot of things branching off and branches on branches on branches. Those have particular biological activity, and the particular kinds of linkages that are present within some of those branching carbohydrates can be very specific to what type of organism or enzyme is required to break those linkages. And that's part of where the real benefit of fungi comes to us as humans, is that consuming these beta-glucans, these complex polysaccharides and starches, helps to stimulate diversity in our gut microbiome. Because instead of just feeding straight lines of starch all the time, having more branched sugars selects for more diversity of bacteria that can eat these very specific linkages. And so this is, we've heard all the time about like the Western diet high in like sugar, fat, and starch selects for kind of just like the gluttonous bacteria. And those aren't necessarily good for our guts. They are things that are associated with inflammation and heart disease and obesity and all this stuff. But the more kind of complex linkages and polysaccharides that we feed ourselves, i.e. complex fibers, greens, beans, mushrooms, stuff like that, whole wheat fibers, and etc., we get more bacterial diversity in our gut as there's specific bacteria that key into eating and breaking some of these specific linkages, which allows them to derive energy. And that's a very good thing for our immune system, for our cognitive function, for our heart health, all sorts of stuff, for inflammation. And so the real benefit I see from mushrooms is just from eating them, from consuming these fungal polysaccharides. And all mushrooms, in some sense, are created equal in the sense that they all have beta-glucans, they all have these complex starch linkages. And so eating mushrooms, period, is going to have a good medicinal benefit. And I get people asking me a lot, it's like, well, what mushroom is good for this thing? And I'm like, well, there's some evidence that maybe certain mushrooms are better or worse for particular things. But just in general, mushrooms are a good thing to eat. And what I want to point out too is that these polysaccharides are things that really, to get the benefit from them, we need to eat them. There's no amount of extraction or chemical modification or decoction or all of these sort of fancy things that herbalists and people do that is better for you than just simply eating the mushroom. And there are lots of mushrooms that are considered medicinal mushrooms, which are not necessarily inherently edible. And what I mean by that is that edibility is defined by suitable to be eaten. And so there's a lot of mushrooms out there that have like the texture of wood, like Ganoderma and Amitoxin, different types of polypores that are literally as hard, if not harder, than much of the wood that's out in the forest. And so I don't consider those to be edible. I do think they can be medicinal because you can take that mushroom and powder it or extract it or do something to it to make it consumable. But unless you can like put it in a pan with some butter and fry it up, I don't consider it edible, right? It's not suitable to be eaten. It's like friggin' wood. We don't eat wood on a regular basis. So I don't think wood is edible, and I don't think a lot of these medicinal mushrooms are necessarily edible, although they can be prepared in a fashion that allows them to be become edible. So that's a thing. I talked about, the immune stimulation, and I think the really important thing there is when we think about these polysaccharides in our guts, they're getting broken down by bacteria and enzymes. Some of those beta-glucans and chunks of those polysaccharides are moving into the lumen of our guts, the sort of cell wall lining. They're getting consumed by stuff like macrophages, different types of white blood cells. And as our bodies and our white blood cells process these chunks of fungal polysaccharides, they spit out pieces of sort of fungal sugar moieties. And that is what is getting incorporated into our immune system. So those fungal sugars are getting added to antibodies, they're getting used as like cell surface markers by different white blood cells, which those fungal sugars will help bind to other fungal sugars and help recognize foreign fungal particles in our bodies, which is part of how eating lots of mushrooms is stimulating our immune system. And the science of that is fairly well defined. I've seen a lot of papers that talk about this, the mechanisms of action. They've shown particular polysaccharides and linkages are having these positive benefits for health outcome. And I understand and see enough data that I believe that there's consensus about this, as opposed to some other things which I've only seen like 1 or 2 publications on, or maybe one non-academic source on something. So I feel very confident in saying that eating lots of mushroom sugars can have a positive outcome for human health, and particularly with regards to immune stimulation. And so in that sense, immune stimulation and modulation by fungal sugars is something I fully and wholly endorse, and say that eating lots of mushrooms is definitely going to give you a benefit for your immune system, at least. And that's a thing that like we always want to be stimulating our immune system and making ourselves sort of as strong against disease as possible. And so that's a real benefit of these consuming mushrooms. But it doesn't necessarily need to be like a medicinal mushroom to get that benefit. You can get that benefit by just eating mushrooms and not necessarily having to go out and spend tons of money on these sort of very hyper-specific extracts and blends and powders and supplements that people are selling to you as a cure-all. So some of the other types of bioactive molecules that are in mushrooms and in fungi in general, there's a lot of secondary metabolites that come out of mushrooms. So sometimes they're like amino acids, there's polyketides, there's terpenoids, or sesquiterpenes and terpenes, and there's sterols, different types of cholesterol-like molecules, there's antioxidants, polyphenols, there's a lot of fungal organic acids and fatty acids, there's lectins and these sort of protein-like things that have biological activity. There's even vitamin D in mushrooms, which is just really good for our immune system and our biological function in general. And vitamin D is something that we synthesize from our skin from sun exposure. But people who live in cold climates and don't have as much access to sun, or people who have a lot of melanin, don't necessarily produce as much vitamin D. And if you eat a lot of animal products, you get tons of vitamin D. But if you're a vegan or vegetarian and you don't get enough sun, or you live in a place where you don't have access to sun, your vitamin D levels can drop precipitously, especially in winter, affecting mood, immune system function. And so eating mushrooms is a pretty quick way to boost your amount of vitamin D. I think that's really cool. So there are a lot of potential good bioactive molecules in mushrooms, particularly in the fruiting bodies of mushrooms, because mycelium, which is the body of the fungus, when it deals with stress, it will shoot its, I guess by dealing with stress, it creates these secondary metabolites. It's a way of sort of detoxifying things in its environment that are giving it trouble. So it detoxifies these molecules and ends up pushing those secondary metabolites up into the mushroom. So with a lot of mushrooms, there's a much higher concentration of particularly bioactive molecules in the actual mushroom than there is in the mycelium. And that's another important point, because when we talk about people growing supplements, I strongly believe, and what I've seen data-wise says that the fruiting body contains more of these bioactive molecules than the mycelium. There is some data to say that like particular types of these bioactive molecules might be higher in the mycelium than in the fruiting body, but the concentration in a fruiting body is still much higher than that in mycelium, because mycelium is inherently kind of not as dense in terms of the mushroom tissue as mycelium. Mycelium is very light and airy and has lots of space in between, whereas mushrooms themselves, all that hyphae are really tightly compacted, so you have a higher concentration of the actual bioactive molecules in a fruiting body. And so when people look at supplements, I always say, if you're going to take supplements, make sure you get supplements made from actual mushroom fruiting bodies, not just mycelium, because the ones made from mycelium are mostly rice bran, straw, whatever they're growing on. So you're paying an absurd amount of money for something that isn't really what they say it is. And I've seen the data to support that, that says that, hey, a lot of mushroom supplements are basically just rice bran repackaged, and there's no real quantification of the bioactive molecules that are in that product. So very specifically, I avoid, I just don't take supplements in general. I just eat mushrooms. But if you're going to do supplements, make sure you get ones that are made with fruiting bodies and not mycelium. And the biggest, most famous mushroom supplement company grows with mycelium. And I think that is disservice to their customers and is disingenuous of them as a whole. But that goes along with the guy who talks about turkey tail as being a cure for cancer, and that whole thing being kind of disingenuous. So he makes a lot of money. He's very well respected. I have met him. I think he's a nice guy, but I do think his business practices are disingenuous. I'll leave it at that. And again, the problem with this chemical data and all these bioactive molecules that are in mushrooms is there's a lot of papers out there that say, hey, this mushroom contains these things, and we showed this fraction of a mushroom had this kind of biological activity. But the problem with this kind of thing is these are really complex natural product mixtures. Often when you do these assays, they're taking like a biochemical fractionation of a mushroom, and they're feeding it to, I don't know, at best mice or rats, or more often they're just dropping something onto a, cancer cells on a plate and saying, oh, we dropped the stuff on it, killed the cancer cells. And I'm like, well, yeah, like it could have just been the alcohol in the extract or the fraction, that you used overwhelmed the thing. There's so many ways that natural products can affect cells, especially in vitro in a test tube on a plate, that it's kind of hard to really define, like, what is the real biological activity. And like, yeah, sometimes they use controls and they use other things to sort of show, oh, this mushroom extract is having more of an effect than something else. But it's still, the mechanism of action isn't particularly well understood. And it's just kind of a lot of hand-wavy stuff. The other problem is a lot of these publications are from China. And there's nothing wrong with China inherently, but the way that publishing works there is different. And a lot of the journals there don't have the same reputation for peer review or scientific rigor that American journals do. So people who try to hype this stuff up and sell supplements are usually citing all Chinese literature, without really citing any American studies to back up what they're saying. And so they sort of say, oh, well, it's in literature. And it's like, well, unfortunately, the people who are putting this stuff together often don't have a critical scientific mindset. They don't have PhDs. They're not experienced in reading primary literature. And what they're reading doesn't set off the red flags like it would maybe for an American researcher who says, hey, this stuff was like, the research was paid and funded for by a company which is selling the product that they're assaying in the paper, saying it has all these molecules and saying it has all this activity. And to me, that's a red flag. You don't want to be funding your own research and then getting your own results, because guess what? You know, when the fossil fuel industry funded their own studies, they said, oh, fossil fuels aren't causing climate change. No problem. We'll just keep using them. How'd that work out for us? You know, so a little bit of healthy skepticism goes a long way with some of this stuff. And I just want to point out too that, you know, these mouse and rat studies that have been done with a lot of these medicinal fungal extracts, that doesn't equate to a human clinical trial with multi-phase ramping up of dosage and understanding. And what has been done, like I talked about at the beginning of the podcast, was isolating and understanding, characterizing, and expressing particular compounds derived from fungi and using those as drugs. Pharmaceutical companies aren't just taking mushroom extracts and selling those as drugs, because that's antithetical to what they do, not because it's like a profit thing where they're trying to somehow like hide the magic of mushrooms from people, just because that's not morally okay to sell a complex biological mixture and say, oh, this will cure your cancer. Like, that's not ethical. And so they can't do that because the FDA won't let them. And there's also no money in it for them. So instead what they do is they go in, they fractionate the fractions, they figure out which particular molecule or compound is having the health effect, and then they figure out how to isolate that, express it in some exogenous system like a yeast or a bacteria or something, make a lot of that compound, and then do maybe a little bit of extra chemistry to make that molecule proprietary to that pharmaceutical company, which again can help with the bioavailability, the targeting, maybe even the toxicity, make it less toxic so that you can add more of it and get more clinical benefit from it, instead of it just becoming toxic to like all the cells in your body. It'll be more specifically directed at like the tumor cell or the bacteria, or whatever it is, the malady that you're trying to fight by using this medicinal mushroom. And again, there's just a big issue with science literacy, because people can look at some of these papers. You can easily Google something and find what you want. You can go online and find endless charts with being like, this mushroom is good for that. But I look at these charts, I'm like, nowhere on this chart is any of this data cited. Nowhere on this chart does it actually tell me what molecule is having the effect. It just tells me, oh, cordyceps for energy and reishi for immune system and blah, 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 blah. And to me, that sets off huge red flags. Because I'm like, I'm a biochemist. I'd like to know what I'm taking and what the effects are and what the molecules are that you are proposing are in these extracts or in these fungus. Doesn't mean that these mushrooms and these fungal things can't have a positive health benefit. I just want to know what they are before I stick a bunch of random stuff in my body. Like I said, I wouldn't take cough medicine every day unless I have a cough. And so I think that's a thing that really like kind of irks me a little bit. And there's a big difference there between like drug discovery as done through science and small molecule and natural product screening, where we're looking for particular biological activity against certain types of diseases, versus herbalism, where people just say, oh, you know, St. John's wort is good for sleep, and reishi is good for this and that, and maitake is good for headaches, and lion's mane is good for cognitive function. You're like, yeah, but like, how so? Because you saying it's good for cognitive function is based on some very poorly done studies that were done like in Asia a while ago, and there's not a lot of like new evidence necessarily compounding this stuff. There are more and more papers coming out and more literature that is building on this body that says that I think there is real medical benefit to mushrooms. But again, it may not be that consuming the mushroom or consuming extracts of the mushroom is where the medical benefit is. It may be in finding like the aranacins that are in lion's mane, isolating those, expressing them, and giving them to you in a form that is bioavailable in the particular isomer of it that can actually help cognitive function as it relates to something like Parkinson's disease or MLS or something like that. And instead of just spending $50 a month on a little container of lion's mane extract, which is probably 90% rice bran, maybe you should be a little bit more critical. And this is probably where people have gotten really angry at me, because I say stuff like this and they're like, well, I've been taking this supplement for years and I feel great. I'm like, yeah, but what happens if you stop taking it? Do you feel any different? And I've heard this from a lot of people, including my own family, where they're like, yeah, I spent 6 months taking that pill, didn't really notice a difference. And when I stopped, I didn't notice a difference either. I'm like, yeah, it's probably a placebo. People who take stuff and believe they will get a benefit from it, get a benefit from it. But if you are really empirical and scientific about it, you may realize that, like, well, maybe this showed a little bit of activity in mice, but mice are fundamentally different. They have different brains, they have different metabolism. What works in a mouse or a rat is a good model for what can work in us, but we're not the same. And the concentration effects are very different. Our bodies are very different. Our digestion is very different. So again, keeping that skepticism alive and healthy, I think, is worthwhile when you think about medicinal mushrooms and we think about, what are some of the benefits we could really get from them. I will sort of finish by highlighting a few things. Let's talk reishi real quick. That's the Ganoderma. There's tons and tons and tons of data, and that's a Ganoderma had been used for many years in traditional Chinese medicine. There are a lot of Ganoderols, different types of organic acids that are in Ganoderma that have been shown to have certain types of biological effects, anti-tumor, antiviral, antibacterial. And again, the reason that these fungi have so many of these biological activities is because polypores in particular are long-lived mushrooms that hang out in the environment for sometimes years, if not many months. And the way they do that is by containing a lot of molecules that fight off mold and bacteria and viruses and stuff that would degrade the mushroom. So this is sort of an evolved thing that over many years, over millennia, billions of years, these fungi have developed a suite of biochemical ways of fighting off what's in their environment, because fungi can't move. They are stuck in place for the most part. They're not modal. So instead of, if it rains, a mushroom can't go under a rock. It has to sit there and take the rain. So it's evolved this huge suite of kind of chemical defenses that are within the mushroom to help it resist rot and mold, et cetera. And that's what we are interested in for its biological activity. So Ganoderma is certainly one that has been pretty well associated with immune function, and I think there's definitely something there. But again, majority of the publications on these mushrooms come out of China, and there are some clinical studies that are happening, and there's some really promising data that's coming out with regards to immunotherapy and cancer and stuff like this. Again, I think the real benefit from these mushrooms is going to come from organic acids, sesquiterpenes, polysaccharides that we're isolating from and defining clinically and biochemically what these compounds as drugs, instead of just being dependent on taking like an extract or a powder or a supplement kind of thing. Because when you get into the extract and supplement market, you really don't know what's in there. At most, the thing they give you is saying, oh, it's some amount of beta-glucan. That doesn't tell you anything about the types of linkages. It doesn't tell you anything about bioactive molecules. It doesn't tell you anything about, most things don't even tell you whether they're fruiting bodies or mycelium. So again, I think that's why it's really important when you look at supplements to be critical, to ask questions, and find things that define the science well, cite their sources. And again, primary literature is hard to read, but it's better to find sources that are like American or European rather than just Chinese literature that's been cited a billion times and was probably funded by a company that grows mushrooms or is actively trying to sell you a supplement. I don't know. There's a cordyceps, which contain a molecule called cordycepin, which looks a lot like adenosine. And so if cordycepin gets integrated into a growing strand of like DNA or RNA, it terminates it because it doesn't have the 3' end to add another nucleotide on. And so cordycepin can be a really good antiviral because it stops really fast growing cells. But again, if you take too much cordycepin or you eat too many cordyceps, you can make yourself really sick because this is a toxin in high doses. So like I said earlier, the dose makes the poison with a lot of this stuff. And also the localization of where these molecules end up in our bodies has a big effect on whether or not they're biologically active and what types of tissues they're affecting. So while I might want to deliver like a really high payload of cordycepin to a tumor cell that's growing really quickly, I might not want to have my whole body bathed in cordycepin every day, because like I'm inhibiting hair growth. I'm inhibiting, the bacterial cells in my gut. I'm inhibiting epithelial cells in my, in the lumen of my intestines, kind of thing. So just think about like, yeah, sure, mushrooms are medicine, but like, what are you treating? What are you trying to treat? And what are the effects that you're getting? And are there side effects to that kind of stuff? Because people just sort of assume that they're like, oh, it's natural, it must be good. And you're like, well, arsenic is natural. There's lots of things that are natural that can harm us. So dose makes the poison. And it's good to understand, what are you trying to accomplish? And everything I've seen about cordyceps says that there's a lot of like studies, but it basically doesn't seem real. There's things out here as a Cordyceps sinensis supplementation does not improve endurance exercise performance. No effect of Cordyceps sinensis supplementation to testosterone level. Randomized double-blind placebo-controlled clinical trial says that it doesn't really affect respiratory health. Like there's all these things that the supplement companies will tell you that cordyceps are great for energy, for testosterone, for breathing. You're like, yeah, but all the clinical data actually doesn't support that. So just, be careful what people tell you, especially if they're trying to sell you something. Turkey tail, which is probably the best studied, most well understood, best characterized medicinal mushroom that's out there. There are literally hundreds of publications about the biochemical activity and the things that are in turkey tail. I was only really able to find a single clinical trial with Trametes versicolor as it pertained to cancer. And it was a terrible trial. It had like 8 people in the trial, 3 of them dropped out. There's only like a few treatment points where they actually assessed the size of their tumors. The controls were kind of screwy. They based all of their data off of like 5 people, and it was essentially inconclusive. And yet there are people out there saying that turkey tail will cure your cancer, ignoring the actual medical benefit of real, well-defined fungal-derived cancer drugs. So just be skeptical, because I don't think there's anything wrong with taking turkey tail. And when like people close to me in my life have had cancer, I sent them a bunch of mushroom supplements and said, hey, take these. But it was because they were having a major health issue. And I'm like, this is not going to hurt. It might help. But as long as you're getting actual medical treatment, try supplementing with these things to see if it will help you. And that's, I think, the best thing you can do with these mushroom things is maybe there's a benefit. Right now, we don't know specifically what types of molecules are the ones having the benefit. So what we're left with is these natural product extracts, tinctures and pills and stuff like that. Take them, but don't ignore don't ignore actual medical advice and what doctors tell you to do. And I've had some very scary moments with people in the mushroom community where they've come up to me and said, oh, well, I got diagnosed with cancer, but I went out and took a bunch of these supplements and now I'm fine. And I'm just like, oh God, like that's really scary. Even if your tumor went into remission, you probably should follow the doctor's advice. You can also take the supplements, but like don't ignore medical advice because you want to sort of do a naturopath herbalism type thing. That predisposes you and your family to some very hard reckonings down the road. And we've seen a lot of celebrities and people fall prey to this kind of stuff because they don't have a science background. They don't totally understand the ramifications of following the advice of people that are literally just trying to sell you something for profit, and they don't necessarily have, even if their heart's in the right place in terms of the herbalism, they don't have the science background to totally understand what could be dangerous or potentially impactful about them selling something that is hype and not actually defined by science. There is some good evidence out there for my Takigrifle Fondosa and some of the complex polysaccharides in there and how they can supplement chemotherapy and potentially make different types of cancer cells more susceptible to chemotherapeutic agents. And again, this is kind of gets back to the idea of what I was talking about with antibiotics, that sometimes if you pair antibiotics together, you're creating more stress on the cell by hitting multiple points in a pathway that is causing more disarray, and it's harder for a bacterial cell to work around. This is a similar idea that maybe some of these bioactive molecules in mushrooms, if we use a chemotherapeutic agent that targets one particular part of cancer cell biology, if you add a few of these other supplemental mushroom bioactive molecules that put stress on different parts of the cancer cell pathway, that maybe you're making it harder for that cancer cell to kind of evolve around the stress you're putting on it. And so that's where the benefit, potential benefit of taking some of these mushrooms as part of the chemotherapy has real scientific basis. But again, you're taking these things in high doses for short periods of time while you're taking chemotherapy. You don't necessarily just take mushroom supplements all the time, because like unless you have cancer riddling your body all the time, maybe you don't need these things, and maybe it's just a waste of money to buy these supplements and these extracts. That being said, eat lots of mushrooms, because the polysaccharides in mushrooms, period, are going to be good for you, and they will have positive outcomes for health and your immune system. I think lion's mane is one I feel sort of potentially the most kind of stirred up about, because I think it's one that people hear all the time. Everyone's heard something about lion's mane and cognitive function. And again, that guy who sells turkey tail extract talks a lot about lion's mane helping with like neurogenesis and stimulating nerve cell growth, axonal growth in our brains. There's a little bit of evidence out there from mice that feeding like high amounts of this arenation and these different kind of organic acid molecules could potentially stimulate some neuronal growth. But again, this is stuff that's been done kind of in vitro, in test tubes, in mouse models. It hasn't been shown in humans. There are potentially some ongoing clinical trials, but again, I haven't really heard the smoking gun come out and say, yeah, this molecule is great. Because I think if that was the case, these drug companies would have already taken this molecule, made some modification, and then done the sort of biochemical characterization and pushed it through clinical trials to the FDA to create a drug that has a very defined particular health outcome. And we haven't seen that yet, which makes me skeptical that these mushrooms do everything that people say they do. Do I think there's anything wrong with taking lion's mane supplements? No, not at all. But I think that if you're going to spend $50 on a little thing of lion's mane pills, you'd be better served spending $50 on actual lion's mane mushroom, cooking it for dinner, eating it all week, sharing it with your family, sharing it with your friends. Getting people to eat lion's mane is a wonderful experience, because most people who say, I don't like mushrooms, well, try lion's mane, because I guarantee you will actually enjoy it. It's got great texture, amazing flavor, and I'm not so worried about the potential medical benefits of it. I just think it tastes good, and I like that. So yeah, it is. Someone in my comments here has commented from a book on natural medicine, which again, I'm going to be very skeptical of a book about natural medicine. Just because you find a citation that fits what you think doesn't necessarily mean that it's true. And this is what I was saying about with regards to China and the publishing history of a lot of this stuff. Is it takes a lot of scientific background to be able to read through these papers. I'm not necessarily an expert on these things. I have a PhD in biochemistry, so I can read primary literature and look at the assays and the methods and the things that people have done. And sometimes I say, this looks like a good paper, the data is good. And sometimes I say, hey, I don't know if this is really legit. There's so much in academic publishing that you have to like go layer after layer and go look at the sources in a paper to understand what they're referencing, what work was done, was this in vitro, was it in vitro, what types of extracts were done. And another thing to keep in mind too, and I didn't mention this, is that a lot of the chemistry that happens in mycelium, I was talking about the secondary metabolites get produced in mycelium, get pushed up to a mushroom, that's community dependent. So whether you have mushrooms that are like wild and you're looking at the natural products in a wild mushroom versus like a cultivated mushroom, something that has a bunch of other wild bacteria and yeast and fungi and plants and interactions may have a far more complex set of secondary metabolites that are being produced to fight off what's around it than something that's just in sort of pure isolated culture. Like I was talking about the yew tree, and that production of Taxol was dependent on this whole ecology of what was going on inside the tree. And so when you culture mushrooms, do they have the same biochemical activity as when they're wild? That's not well understood, and that's not well defined. So people make a lot of these health claims as if they're referencing one paper of like something like chaga. They do this all the time. They say, well, chaga contains all these things, But our grown thing may not contain all of the same molecules as that wild extract from chaga from Russia, because we're growing chaga, in a controlled setting in a lab, and we're not even taking chaga. It's not a fruiting body, but a chaga gall, and instead it's mycelium. It's all complicated, and I'm not trying to say that medicinal mushrooms don't have value and that there isn't really good things they could potentially do. I'm just encouraging a healthy level of skepticism and trying to get people to recognize that some of the benefit of the biochemical activity may only really be recognized in human health once we've done more characterization and isolation of these molecules, and that simply consuming extracts and powders of these mushrooms, supplements basically, may not have the health benefits and outcomes that you think they do. And I'm also skeptical simply because people who sell this stuff tend to repeat the same health misinformation a lot without being critical of their own product or trying to really understand the science behind it. And or if they do understand the science, they go very surface level and say, oh, look at these papers that confirm my confirmation bias kind of thing. So that's my soapbox on medicinal mushrooms. I get asked about it a lot. I have referenced a few of the things that I think are important. I am not trying to tell you what to do. If you've had positive health outcomes from taking mushroom supplements, that's awesome. I'm so happy for you. Keep taking them, keep doing what you do. But just be aware that being critical is not a bad thing. Asking, where your supplements are coming from, asking what's in your supplements, asking the method of growth, talking to your producer, because a lot of supplements too are just things people are just buying dried and powdered stuff from China and then repackaging it. And that's fine, but maybe it'd be better to buy supplements that are grown here in North America. Maybe it'd be better to buy supplements that are not shipped halfway across the world. Find a local farm that's growing some of these things and, get what's local. Get mushrooms that you can actually go see, smell, and touch instead of having something that's been powdered in China and you don't know how long it's been sitting there as a powder. It could be years, or buying something that's been bought bulk on wholesale market and the data, the analysis they have is from some lab somewhere else. There's a lot of questions to be asked here. And I'm simply encouraging people to think for themselves and not just take everything at face value when it comes to medicinal mushrooms. So with that being said, I hope you guys enjoyed my thoughts on this. If you want to learn more from me, please check out my website, fascinatedbyfungi.com. I've got some cool merch on there. I've got answers to a lot of your most common mushroom questions. I've got the links for all these podcast episodes. I have a YouTube, I have a Facebook, a Pinterest, an Instagram, a TikTok, all these social media things. So if you like what I do, please check me out. If you want to support me, I do have a Patreon. Like I said, I also have merch you can get on my website. Yeah, I don't know. I'm enjoying this podcast. I think I'm having some good discourse. I'm probably going to do 1 or 2 more episodes of kind of monologuing and sharing my thoughts on various things. But if you guys have feedback for me, want to hear me talk about a particular subject, please feel free to email me, fascinatedbyfungi@gmail.com, or you can always message me on Instagram. I will try to check those. And at some point here, I think I'm going to start bringing guests on, and we're going to have some fun, dynamic conversations about mushrooms. And if there's anyone particular you want me to talk to, let me know. I will take your feedback. But until then, I'm wishing everyone a wonderful Sunday and sending much love to you all. So be well, and I will talk to you next week. Bye-bye.